I've been working on this Dalek for a month or so, and I've finally completed it. I have one working model here. It's already done, and then I'm going to show assembling as best I can with these parts back here, the second model of it. First, I'll demonstrate it to show you what it does. It's got a power switch down here. When you power it up, it'll play a little sound bite to let you know that the power is on. Then you have to push the switch. It will have 24 sound bites in it. This one only has about 10, but the one over here has 24 in it. I'm not going to play too many of them in case there's a copyright problem. As you can see, well, you may or not, I'll try it one more time. I've got so much light on this to get decent video, but you can hardly see the LEDs. There are two LEDs in each one of these little lights. One is controlled by the MP3 player that plays the sound, and one is controlled by the Picaxe microcontroller that flashes them periodically. I'll turn it off now. The little, as you can see, the little arms are animated, and there's some animation on this little, on the head that rotates back and forth. This is posable, although I never could get, or never was happy with the way it ended up. It's kind of loose. You could just pick a spot and glue it in place, or just leave it like that if you want. When we assemble it, you'll see what's going on there. What's inside of it. The heart of the project is this circuit board. This is an MP3 player. It's a DY7V17F. I think it has like 4 meg of memory. Doesn't have it. Its memory is on board. It doesn't have an SD card like a lot of them have. Underneath the MP3 player is a Picaxe 14M2 microcontroller, which runs a interpreted basic. The Picaxe controls, reads the switch, sends serial commands to the MP3 player to play files. There are 24 different files I have loaded here, and turns on the motor to this mosfet. I have a couple of extra I/O lines coming out in case I wanted to do something different in the future. I know this is going to be a part that's going to keep almost anyone from building this circuit board, but if you wanted to build it, I will put in a zip file in the on Thingiverse and wherever else I upload this to, the Easy EDA files and the Gerber files, so that if you wanted to, you could order this board from like PCBWay, and I think it would produce right. I made it on a 3018 CNC with isolation routing, so it was designed to be produced that way, with big thick traces and fairly large holes for the parts. If you were to buy it from like one of the PC board places, it would be a two-sided board. I don't want to make a two-sided board on my CNC, so I just have these. I think there's like 5 jumpers. These would be your top traces on a real board. There's a power up here. There's an extra power takeoff in case you wanted to power something else from the batteries. Okay, we'll start over here. Here's where the batteries go. It has a proper battery compartment. I wanted to design that in like a normal toy would have. These little clips, you can buy them on places like Amazon. They're for either an AA or a AAA battery. Here's what they look like when you get them. And you just design them into your project. Solder. I have these little lines here actually in the prints. I just highlighted them with a black marker, a polarity, and these are where the jumper wires go to properly wire it. And then your power to the switch goes from here to the switch, and it'll go over to the board, the positive, and the negative just goes straight to the board. This little part right here, the bottom of it, is a print in place. So this hinge, it's all printed as one part. Will come out pretty nice. I'll put the batteries in it, and that part will be done. I think I used an 8mm screw right here. Some of these holes look kind of ragged. In the file that I put on, that I will upload to Thingiverse and the other sites, there will be a sacrificial bridge here you'll have to drill out, and that will make this hole much cleaner. It's just all a sacrificial bridge is one layer of filament there that keeps it from trying to print in midair. So let's see if we've got everything wired up here. This part should work. Turn it on. You can see a little motor going around. I have to play too many sound bites. I'm worried about copyright. Here's a little N20 motor, 30 RPM, 6 volts. You probably wouldn't want to go much faster than that. It would look pretty wild. Here's a little cam. We're going to start assembling it with the cam. Here's the little arms that are going to actuate these. This is the gun and this is the arm. There's a little plate that's going to hold those in. We'll get to that in a minute. This part right here is different than this one. I went ahead and added these. I think they're supposed to be solar panels. These are all just glued on. As the little hemispheres are also just glued on. I used weld 16. You can probably use super glue and get away with it. The weld 16 can be kind of messy. We'll start right here with this part. This first part of the crank or cam, whatever you want to call it, just pushes on. The motor I used has a flat like this. It's not quite as long as some of the motors I used to buy. So if you try to make this and you have a different motor, leave a comment on the Thingiverse or somewhere, and I'll try to modify the file, make it work for you. You just press this on. There is a little line down here that's printed in that shows you where the flat goes to help you orient it. It's can be kind of a pain. Now these little arms, one of them goes like this, and one of them goes like this. So there's a flat on here. And you put this on with an 8mm long 3mm screw. Make sure this is all working good. This is the motor mount. It also has a guide in it for the little arms. You can see how that works. There's 4 8mm screws here. Don't get too crazy tightening those screws because that's just threaded into a plastic. Once again, we'll turn it on. These are what drive. What it amounts to is these extend through here like this. That's all there is to it. What drives the head rotation, what little there is of it, is this part right here will be rocked back and forth a little. And this part goes up through here and spins this head a little bit. We'll get to that later. Next, we're going to mount this part to here. This is funky foam, 2 pieces of it cut out in the shape of this. The reason for this is to try to dampen down some of the noise. The motor is very quiet, but when you put it in this big plastic box, it can start getting loud, and then it kind of overpowers with sound bites. So I don't know if this helps much or not, but it doesn't hurt. It's just 2 pieces of funky foam, they call it. Let me see how big it is, how thick it is. It's about 71.71 millimeters. I'm going to use some more 8mm screws. Oh, these thread up from the bottom. Well, that's done. I'm going to point out a few things on this board. I've just got it marked with Sharpie. These 2 terminals are where the motor goes. Doesn't matter the polarity. The first one here, this is where the LEDs controlled by the Picaxe goes, and the polarity does matter. These LEDs are wired in series like batteries, and the cathodes are going to come to this black spot here, the top of it where the ground is. The cathode is just directly to ground, and the anodes go through a current limiting resistor to the, no, I got that wrong. The anodes are connected straight to the positive voltage. The cathodes are connected through a resistor to the Picaxe I/O pin, and it pulls the line low to turn the LEDs on. This is the programming input jack. The USB connector here is how you get the files into the MP3 player. What I'm going to do now, we have to put the switch will go right here. We can put that in now, I think. There is a little clip I designed. I think I'll probably end up gluing the switch in also with some hot glue. I'll try to get this in frame. The switch goes in that hole. I'll take this loose so I can get it up closer to look at it. Maybe that's as deep as it goes, can't remember. This little, well, you got them bent around now. This little thing here is going to clip them on. There are little dedents in the side of this. But these details are so small that they really don't show up or come out good in FDM printing. I don't think I'm going to be able to do this with a camera in my face. I'm going to pause it and then fix that problem. Well, I got it in there. As you can see, it just snaps over here. What I think I'm going to do is I'm going to put a big blob of hot glue on there just so it doesn't come loose. First, I want to see if I have to kind of maneuver it around. Hope this is showing up in there. To line up, we have a little button we're going to put on there, hopefully. You can make this button a different color if you want to. You may have to do a little bit of work right there, so in this hole, so that it'll fit down in there. I'm going to push this down with my finger when I put it on there. It seems to work pretty well. Probably sets more proud than I wanted it to, but that's okay. Let's see, what else do I need to do? Oh, I'm going to do some hot gluing. I'm also going to hot glue the speaker. I'm going to hot glue the speaker in right here. What I'm going to do is I'm going to put a big blob right down here on these wires, because these wires are very small and fragile. It's a 28 millimeter round speaker. And I'm going to put some hot glue there so that these wires aren't constantly being flexed. They'll break right here. So I'm going to pause and go get the hot glue gun going and just glue that and the switch in. Well, I got the speaker glued in with hot glue. Lots of hot glue. On the switch, I decided instead of using hot glue, I used this Weld 16 or Side Grip 16. It works very well on PLA. Other plastics I'm not sure about, but it works very well on PLA. It's a solvent-based glue, so these two things here are probably never going to come apart without breaking them. That's the idea behind it, because I didn't want that falling off. I didn't want when the button gets pushed to allow the switch to move back out. So I think that'll work. So those two things are done. I think what we'll do now is work on this top part. This is the, let's see, what else we need. This is a stacked type thing. There's a little pin right here that presses in there. I've just got it pressed down. I don't think it'd ever come out, but you could glue it in. What it does, it limits rotation to 90 degrees or approximately 90 degrees. The main reason I did that was in case people want to build this as just a static model. It won't just sit there and spin around and around. Or they want to put some LEDs in it. It might twist the wires off. But this is a stacked up construction. I borrowed this from another Dalek I found on Thingiverse. I gave him credit in the first video I showed on doing this. I don't remember her name right now. Audrey something. I think it's after the movie about the big plant. We have these pieces that are just stacked. There's a key here. They do have to be, all three of these are different. They're different sizes. We'll have to figure out how they go from. I don't know, a funky thing to put together, but that's the way those stack up. This will go on here like this, and then this goes on here, and this is the nut that holds it all together. But first, we have to mount this to this with a couple of screws. But before we do that, we have to run our LEDs up through all this mess and glue them into these little light things here. So the way I think I'm going to do that, I think I'll go get the hot glue gun and just I do have these. See, the one with the black mark is the one that is controlled by the Picaxe, which does have a polarity, same as the L down here with a little black mark. So that's where that wire goes. The other ones don't have a polarity. Hopefully these are going to fit down through there. I opened up that hole from the first one I built. But these are going to go down in here like this. I want to go glue these into the these are 3mm LEDs, not 5. If you were just going to put like a flashing LED in there, didn't want to go through all this, just maybe you just want to put a couple of flashing LEDs, you can just stick a 5mm in there. It's sized to fit. I'm going to put this in there. It's going to be kind of a finicky thing to do. I won't be doing it on the camera because I'll never get it done. I'm going to poke those in there like that, poke them up in there and glue them in. So I'm going to pause and go do that. I'll just use hot glue. Well, I have the LEDs hot glued in. Hopefully it's in there good. I'm going to plug it in and see if it still works. So the ones with a polarity marked, the black wire goes through that black dot on the LEDs. The other ones are marked, just go to the L. Need to plug in some power. I won't plug in the speaker so it won't play with sound. Just got to make sure I get that polarity on the power right for sure. Black wire to a negative. Turn it on, I won't hear any sound, but should see the LEDs flicker. There they go. Yeah, and they're blinking. So the first one's blinking were the 1206 surface mounts blinking from the speaker output. And the ones that blink periodically are the 3mm hooked to the Picaxe. So that's good. It's easy to break those wires. Now what we got to do is tighten this all or lock this all up. We'll use 2 screws right here. Otherwise, you could probably just put a bunch of hot glue on there and glue this down if you wanted to, lining up those screw holes. I'm going to get a couple of screws though, just in case. You do have to pay attention to the front and the back though. Can unplug this. We'll run these down through here like this. Because of this limiting, the pin that limits the travel, you have to pay attention to the front and back. So the back is where this key is. In the front of the dome is where the little eyeball socket goes, or whatever you want to call it. So what we'll do, I think I'll mark those so I don't get screwed up. I'm going to put this hole to this one. So I'm going to go get some screws. They're going to be 2mm screws, and I'll figure out the length here in a minute. Okay, the screws I'm using, well, you're probably not going to be able to see it. It's a 2mm diameter. It's these black self-threading plastic screws. I didn't have the proper length, so I had to cut this down to 6mm. This is the length of the thread. I've already got one in. I'd like to use all the same 3mm screws, but there's just no room right here. Like I say, you could probably just get by with just hot gluing this together. Put a bunch of hot glue up underneath it. Don't get any down here. This has to spin freely. Don't let that screw get too long. It'll poke through. So that's good. This just is a demonstration for now. This eye stock is what it's called. I never was happy with what it ended up. There's a little bump right here, and right down in there, there's a modeled in a arc. You'll just have to push that down in there. It's not too bad, but it's not what I wanted. You can pop it out too. Let's go ahead and finish putting this together. What I'm going to do, well, we can go ahead and do this part too. This is the little tabbed part. This is the part that gets engaged by the cams to make the head move. You have to put it in a little tab in the front. There's a little nut. When you make these wires, you want to make them plenty long, because we're going to have to plug them into that board. I should have measured the distance before I assembled all this. This should move freely. What I think I'm going to do now, I'm going to go in there, I'm going to go get my glue gun going again and put some glue down in here so that there's no strain on these wires up in there. So I'll pause and do that. I'll put some hot glue down in here to relieve some stress on those wires, hopefully. While we're waiting on that to cool, I'm going to work on this part. I think this is called the shoulders or gun box or something like that. I got the information for making this from the Dalek Builders group. You have to join up to get any information from it, but they have a lot of good stuff on there. The dimensions they give are for building full-sized ones like you would ride around in. So this is 10% of those. but all the dimensions for like these profiles right here, they all came from that. All the sizes of the hemispheres, all the dimensions came from it. Now, these little parts right here, the arm and the gun, I printed that in clear. This is 3mm brass rod. These little balls come in 2 halves. You put them on there and glue them together. You have to get these lengths fairly accurate for it to work. So the gun, you want 17mm sticking out the back, 30mm at the front. The whole tube is going to be 57 long. The eye is just this eye stock was 40mm long. This little thing here is 2 parts. You just glue them together. There's a pocket in there for the brass tubing to go. This is just glued on, and this is glued on the end. The arm tube, 19mm hanging at the back, 46 at the front, 75 total length. I hope that's about what I've got here. 46, 18.5, 74, close enough. 58, 17 almost. The reason that these dimensions, especially the ones out the back, are important is these little bosses here, they'll hit these mining bosses. The gun goes in the pocket on this side, its left side. The arm goes in this pocket on its right side. This little part here, it's marked out, and it's the clamp that holds these in. We're going to put a screw in here. For the purposes of this build, where the motor will be moving these around, we want these to be fairly free. Actually, we want them to be free. If you were going to build it without the motors and everything and just wanted a static model that was posable, you could lock these down until you get the tension to where you want them. So we're going to need an 8mm long screw, I think. Oh, there's a little ridges too on this. It prints with the lettering down. Anyway, you can tell by the lettering how to orient it. I put that screw in there at an angle, model it in at an angle, just to make it easier to drive this in. So it doesn't fit flat against there. Like I say, if you wanted it posable, that's how you tighten it down like that. They'd stay put. We don't want that. We want them to move around freely. We just want them captured. It's pretty good. Okay. Now we'll feed these down through here. There is a little key right here and right here. What we're going to do is glue this together. It might be easier from what we're doing, the way we're doing it now. It is made to where you can, after you glue this on, you can still assemble it by sliding this up. Well, this will be on here like this, and you'll be able to slide this up on there and around those. But for purposes of what we're doing now, I think what we're going to do, we're going to assemble the rest of it, get it working, and then glue this on at the last from the top, like that. I think it'll be easier just to do it that way. So, let's see. This is going to go on here like this. I'm going to use 2 more 8mm screws to hold it on. Put a chamfer on that. You can do stuff like that ahead of time and make your life a lot easier. Okay. I ought to think about sliding this board in now. We'll wire up, put all our wiring on there. Speaker. There may be a flaw in my plan to do it this way. The board will slide in like this. There's little slots right there. It'll slide in like that. Let me take a look at this for a minute and think about it. This part fits on here with 2 more screws. There's sacrificial bridges. There's a sacrificial bridge right here. You can drill those out. Well, I'll show you how these go right now. You just put those tubes in the holes. Hopefully we can get them in there. Like that. And I think I've figured this where you can get the screws in there. Now once again, I need to clean those holes out. These parts print with support here, that's why they're so rough looking. That's the way it's got to be done. And once again, we got to feed those through here. Might want to go with like a 10mm screw on these. I think I'll pull that one out and put a 10mm in, or 12 even. Now let's see if we can actually assemble this thing. That's where it gets interesting. Make sure these wires are long. Let me measure those. So I don't know, 6 inches to there, or 150mm from here. So there's another probably 40mm up in here. So a couple 100mm long. We'll put this down through here, trying to hold it where it goes approximately. Yes, we've got enough wire to do it. So what I'm going to do, I'm just going to glue this right here. You can see how it works. So let me plug it in and let you see that operating. Okay, let's turn it on. And this one right here will engage this tab right here. So let's glue its head on. Don't think I'm forgetting anything. I sure hope not. To do that, I'm going to use weld 16. It's a really good glue. It just makes a mess. Yes, just right there. That's where we're going to glue it. And it sets up very fast. I think I got it in the right spot. Yes. Stuff sets up fast. It's a solvent-based glue. It actually melts the parts together. Should turn it on and make sure it works before I go any farther. Now I have to plug in those LEDs. The board's going in like this. The ones LEDs with the polarity mark go down here. And then the board slides in. Right here. Try to do what you can with the wires. Fortunately, this stuff doesn't move very much, so hopefully the wires aren't going to be a problem. Let's see. Now we just need 4 8mm screws here. Let's turn it on again and see if it works. Have to do one thing to finish it. put some of these things on it. Make it a little quieter. So there it is. It feels quite substantial. It's fairly heavy. So well, dueling Daleks, I guess. The switch I used was a 3-position switch. Doesn't matter. You just have to push it all the way one way or the other. Oh, it's this thing here moving around. This one's a little bit tighter for some reason. Well, if you want, you can build it 2 different ways. You can build it with these slats or without them. Both parts are included. The one with the slats have got, we got one over here. The slats have got a tiny little raised part, a little hemisphere thing here, and there are, in this part over here, there is a little indentation for each one of these to be glued into. And there's 2 different sizes, short ones in the front and the long ones in the back. What else do I want to say? It turned out okay, I guess. Oh, there's one other part I forgot. That goes on there. I'll glue that on. I don't think I have any parts left over. You glue these hemispheres on separately, obviously, to make them easier to color different. You wouldn't want to paint them. Well, I'm going to put all the files on Thingiverse and the other normal places. There'll be a file that contains the Picaxe code. See what else will be in it. There'll be easy EDA files, the Gerber files if you wanted to make the board or order the board from one of the board makers. What else? Well, I think that's about it. I'm going to make a short demonstration video of it next, and thanks for watching.